Welcome everyone, and thank you for joining our 9th session this year, where we're talking about analysis and results, interpreting and reporting. Josh, can you go to the next slide?
Sure. Okay.
All right, so we're here today because we are part of the 2030 working group, and as you all know, recently the IPCC came out with their climate report, and not so shockingly and surprisingly, climate change is already here, and we have to, as designers, start working towards reducing our impacts on global warming. So next slide. Josh, next slide. Oh, thank you. Buildings generate nearly 40% of annual global CO2 emissions, and building operations, so that's total emissions, building operations represent 28% annually, while building materials and construction, or the embodied carbon, is responsible for an additional 11% annually. And as architects and designers, we have agency. If you can go to the next slide, Josh. Signing up for the 2030 commitment is a way that we can start to reduce our impact on the environment. There are some common myths that it takes too much time, it requires too many resources, or you can't report if you have poor performing projects, and that you have to achieve the target and projects must be complete, but that's not the case. The fact is that for each project, it takes fewer than around 30 minutes to gather the data that's required for reporting, and it's free. We have mentorship available through the AIA to do the documentation, and everything's anonymous. It's not a report. You don't have to have great performing projects. We want to, you can't manage what you do not measure, and so that's what this is. It's a measuring tool. And making progress is more important than hitting the targets. So it's okay, go ahead, Josh.
Sorry about that.
Got distracted with my little one screaming in the background. Become a 2030 signatory today. It's really a 3-step process. If you do it today, it's signing a commitment letter, creating a sustainability action plan, and reporting your projects to the DDX in the first year. And then in year 2, you try to meet the targets to the best of your ability. And in year 3, you make sure you update your sustainability action plan while you're doing steps 1 through 3. So if you're not already a signatory firm, please sign up today. And awesome. And speaking of those resources, through the AIA, there is our Philly Coat chapter videos from all of the sessions that we've been doing are recorded and available on the YouTube page. So you can always go back and watch ones that you've missed. There is a sample sustainability action plan guide that's available that will help you create a sustainability action plan for your office. And then we're also offering office hours, and look for additional times in our newsletter for when you can meet with someone from the 2030 working group to tell you more about the program. So that's it. Next slide. So for today's session, there is a link in the chat box. If you need AIA credit, please do make sure you sign up. And we're going to be taking questions also in the chat. So at any point during the presentation, if you have a question, please feel free to drop them in the chat box. And the session is being recorded for availability later. Okay. Thank you. And with that, I'm going to pass it off to Josh, and he's going to get started with this session.
Great. Thank you, Janki. So as Janki mentioned, this is the 9th session in our Breaking Down Barriers to Building Science series that we started back in January. And what we wanted to do here was try to start to pull some of those lessons together. Also just kind of recap and kind of remind ourselves of all the kind of areas and building science that we've looked at over the past year. There's definitely some familiar faces here in terms of presenters, and we wanted to kind of present from our group as well, to try to share that back with and send people back to the other talks in case you missed one, and highlight some of these lessons that we've learned along the way. So today's learning objectives, we are going to be focusing on how to interpret and report our data. And in doing so, we want to kind of remind ourselves of the different types of analyses that we do for different aspects of building science and how they contribute to design decisions in our projects. We do want to highlight a couple of different tools. We're definitely not here promoting any tools, but there are definitely tools available across the spectrum that do different things that can be beneficial to your projects. And we also, and generally wanted to help in this talk start to discuss, and definitely this talk is intended to be a discussion. So as Jonky said, please do drop questions in along the way. What to make of your data, and this talk is really going to be the first part of this analysis and results talk. We're going to do another one next month that's highlighted, that's focused a little bit more on kind of more finalized absolute analyses. But we're going to focus in this talk on the comparative analyses that architects may be pursuing on their own, and how to kind of look at that data with a critical eye, and based on and we're going to have a couple of presenters join us today who are going to demonstrate through a couple of different tools how those analyses may work on a typical project, and help us kind of make sense of that and evaluate how reliable they are, what they should be used for, and so forth. So as I mentioned, we're going to kind of go through these three process kind of tool examples after we do a quick recap on the building science series. Then we're going to talk a little bit about the next steps of reporting to the 2030 commitment. And we certainly encourage questions along the way, and we're planning to allow ample time for that discussion at the end. I know we've gotten some questions already. So looking back at our year, which has been a busy year, we certainly have, I think, covered a lot in a fairly quick amount of time, but we wanted to really, as the series title says, kind of break down some of these barriers, and in some cases introduce these topics, in some cases go a little deeper, try to give everyone some tools to go forward and to ask questions during their design processes that will enable higher performing projects. So as we all know, design decision, buildings embody a multitude of concerns and questions, program, other things. And each of our design decisions potentially has an impact on efficiency, comfort, spatial quality, and the use of resources, as each of these talks have kind of highlighted. And with looking at each of these topics, we can find ways to enhance the performance of our projects. And as we mentioned, there are numerous tools across the board to look at different aspects, from daylighting to energy, obviously, and thermal comfort. So we'll kind of get into this, and looking back at the year, we wanted to highlight a couple of the maybe some of the most highlighted points from these talks. And energy modeling is definitely a major concern with the 2030 program, where our ultimate metric is the predicted energy use intensity. So certainly we want to understand how to get to that number, how to identify our targets, how to model options, whether they're single aspect or whole building, what questions we can ask in the early phases versus the advanced phases. We talked about bioclimatic design, and there are decisions we can make even before we know what the building is going to, what the form of the building is going to be. There are things inherently related to the climate of that building, to the site that are relevant decisions to make up front, and can really make a big difference towards getting towards that 2030 goal. I think the overarching theme of all of these talks, if I could say there was one, is that you have to make these decisions early. That's the only way to really truly get to the goals of the 2030 commitment, to get towards carbon neutral. Thermal comfort, the simple questioning of temperature set points and thermal comfort range, identifying what the building activities are, and the impacts of fenestration on comfort on the inside of the space. Similarly, with the kind of dual aspects of sunlight and daylighting, there's too much sunlight, there can be too little sunlight, and daylight can be used to a positive, and there are ways to orient your building, design your building to maximize its potential to use solar energy to benefit the project. And embodied carbon, a topic we touched on last month, again, is that chart that Jonky put up at the beginning, identified, gets into the non-operational side of the carbon usage of the buildings, but it's 11% of that, or really it's a quarter of that, almost 40% that buildings are responsible for. So again, this is our charge as architects to implement these lessons. So, getting into and setting up the presentations for tonight, we did talk in our early sessions this year about the difference between comparative and absolute analyses, the types of simulations that you're going to look at early in a project: climate insight, programming, benchmarking, how you can ask those questions up front. And then as you start to get into developing your design, using these tools to go through iterative studies. We'll see some examples of those tonight as well. And as even before systems are selected, and then as systems are selected, kind of integrating the whole building together, determining your load, determining the impact of all of your early design decisions on setting those loads. And then finally, as we're going to focus on more next month, the kind of verifying the as designed performance as you get to the later phases of the project, as you get to perhaps submitting your lead energy model, those types of exercises. So we talked amongst our group about kind of what some of these what we wanted to, the questions we wanted to ask in these presentations. What questions are you asking as a designer, and when is the right time to ask them? How do you identify the parameters that are going to be most impactful to your project? Maybe there's some kind of obvious contenders. And then as we get into the outputs of these studies, what does that data tell us? How do we use it to make design decisions? And again, in the comparative frame of reference, we're looking at how those decisions create differences between the schemes. For example, not so much what the exact number output is, but what the relative conclusions are from those comparative studies. And then as we get into the more developed schemes, how do we evaluate the energy use look at reporting to the 2030 commitment to the DDX, and kind of evaluating this data in at the end of the process. So that leads us into our presentations, and we asked around, and we had a couple of our members who were interested in presenting different tools. We have Sherman Aronson, who's a regular member of our committee, who is going to be presenting some of VLTA's earlier Cove tool evaluations. How that tool can be used to ask some of these questions, make some of these decisions. We have Daniel Overby, who's joining us from Browning Day, who's going to give a demonstration on Sothera, how these kind of investigations can be pursued, and then Apoorv Goyal, who's also been a regular member of our group this year, and then contributed to a couple of our presentations, and he's going to be doing the same on Climate Studio. So I think a good range of tools, a good range of approaches, and with that, I'm going to go ahead and get into the talks. And Sherman, I will pitch it to you if you are ready to share. You're muted there.
Okay, yeah, let me share screen.
I'm going to stop.
Oh, okay, I will do that again. Let me put it on full screen.
There we are.
Okay, that looks a little big on here. I guess you can see it seems to fill up a little too much there. Well, can you see the whole image? Yes. So that's better. Yes, we learned about Cove tool at one of these sessions earlier this year and late last year, and for a long time at VLTA, we've tried to use various kinds of plugins, Green Building Studio for a while with Revit. We got way much information and variables from that, and hard to pick and choose. We tried eQuest, and we could get through a little bit of it, but not all that far. So this summer we decided, after some experimenting, to get a few licenses with Cove tool and see if we can use it for energy and for the other aspects of green design that are built into it. So this first, so I'm going to show three briefly, very brief building types and building examples. This first one is a small, medium-sized office building. It's kind of imaginary for the Cove tool study, but it's based on a recent project we completed a few years ago. And the entrance, the way to enter the information in this case was very simple. I made a sort of hand drawing on Bluebeam of a volume of a building and assigned 50% glass areas, and made a rough sketch, and then put that data manually into the program. So in that sense, it's a little bit like ComCheck. It's just basic information on the envelope. And we chose the 2009 energy code, and we had it oriented east, so the long sides were east-west, actually, and it was 50% vision. But let's see what happens. And so the next slide, we get those questions were asked. What is the projected energy use? How it's based on massing and orientation, window to wall ratio, the version of the code used, and we got some answers. Baseline energy of 50, and it shows it's sort of mid-range between national average and the DDX targets, but that was very useful information. And it shows a report where you can read the output, you can interpret it, you can understand it pretty clearly. It does include the PEUI right away. So then we made a stab at adjusting that building design, making it so the long sides are facing north and south, reducing the window glass area to 40% on those sides and 20% on east and west. And we updated it to the 2018 code and ran it again. And there we get a PEUI of 30, which is a dramatic improvement over the previous results. And it's about 67% less than the national average of 85. And if we were submitting this, we could use this data for GDX reporting. And you could read what the assumptions were for envelope and glazing. So pretty much what it's working from is standard R values and U values that are built into complying with the code and glazing values. And that extrapolates a good deal of information from that. Also, systems, basic system assumptions. Any of those you can adjust and tweak and change. So next step is optimizing. And it has a tool built in where we can ask the question, well, what are the design options that we could explore if we want to reduce it even further from the 31 PEUI? And there's a range of options which can be fine-tuned. If you select one of these bars, you can just say 100 tons of CO2, or you could adjust the range based on the cost premium or the payback. So this provided a range both as graphically, this set of bundles, you can create a report, but we downloaded this as an Excel document. And then once it's in Excel, we can sort it by any of these parameters. So we decided to sort by steel framing, because we're not using wood framing, and look at what it proposes. So here we went, it might be hard to read on your screen, but went from 31 in that bright yellow band down to 27.6. And one of the major changes is using improved glazing. We actually have a VNE number for a product, as well as adjustments to occupancy sensors, and it with very little additional construction cost. So this is a kind of tool that we can use during design to discuss with the engineers and the owners. It also provides graphic output on climate, sunlight, the psychrometric chart, radiation. That's based on the location. It's an output that it varies with where you are and the type and size of building. So this is useful for other kinds of decision making. Another case was a high-rise multifamily residential apartments, a large building, and this was based on the IECC 2009. It does have a south-facing facade, but a little more than 60% vision glass, and this came up with a PEUI, you can see, of 74. What's interesting to note about that is it's not especially, it's about 20% less than national average, but it also was not far off from what later was developed by the engineers at 78. So that was good to know. And again, we looked at bundles of optimization options. There were about 20 or so that could be considered, again, mostly to do with glazing, since there's a lot of glass on the building facade, but there was significant added cost for moving from 74 to 52 PEUI, for instance. But if we could dig into it further and look at the variables, there may be other options to consider as well. We also used the tool for the owners who were interested in a study of glare, view, and daylight analysis, and that was helpful as well. And the last mini case study is a mid-size multifamily residential project, large but lower rise and newer. So it's still in concept design. And what parameters do we have? Well, here again, that we're complying with the 2018 code. It's mostly organized with long views on the north and south walls, and the window wall ratio is less than 50%. In fact, they're targeting 40% with high quality insulated solid walls and throughout. And this gives us a prediction of 35 PEUI, which again, it's easy to find. It's front and center in the presentation. And then we ran an optimization where we can continue to look at possible improvements to that, but that is a very good result for this kind of building for today's market. There are some improvements that could be made to reduce it to 31, which is like a $1 million cost premium worth evaluating, and to see what else we can do with it. But this is the beginnings of how we've only been using it for a couple of months. We're starting to use this tool in early concept planning. And I have good hopes that it will get us to a point where our architects can understand the variables involved and the terms and be able to then talk with our mechanical engineers and civil engineers to get a better handle as they move forward. It shouldn't be that far in a discussion. And also, in a way, it is, like I said before, a bit like ComCheck. It is reachable for basic information, not an in-detail model, but good enough to get a lot of insight in the beginning of the project. So that's where we are, and that's what we're sharing today. Okay, I'll unshare the screen.
Great, thank you, Sherman. I think that is a great illustration of how, and I think your point about how these tools can educate architects, on the impacts of these types of variations, options, is kind of an important point, and part of why we're highlighting some of these tools. So with that, Dan, I'll let you go ahead and share your demo on Saphira.
Okay. If you can see SketchUp on the screen, then the screen share is working out well here. I'm going to actually try to share a few different things. I was telling the group offline before we kicked off. I should have done what Sherman did and show you prepared slides so that less things can go wrong. But I'm going to be a little bit wild here and actually give you a bit of a live demo into Saphira and hope that everything works out perfectly. Just because I felt like in this moment, I was with many of you earlier in the year, and we talked high level on some of these tools and thought we'd just jump in and try this out. So what you see here is SketchUp and Saphira. If you were to use that energy modeling platform, it is also cloud-based, just like Cove Tool is. You would have to, in order to access the plugins, you have to go to the Saphira website for Revit and SketchUp. They have their own respective plugins. You install them, and if all works well, you can see my Saphira plugin menu box appearing here. So what I have modeled here for you is a 5-story office building in Boston, and it's near Fenway. And when you open up the Saphira plugin, it's going to want to interpret whatever is on your screen. So if you don't want, let's say, the 5-block area that I have highlighted here to be part of my analysis, I want to turn that off. So Saphira is going to take whatever you're showing. And you can see here, I've reduced this model down to very simple planes. And in this first little menu box here, I'm going to go to Entity Palette. I'm going to click this Show Entity Types. And you see this list of different types of enclosure components: roof, floor, walls. It's very simple. You get one type of opaque wall. You get one type of floor, one type of roof, and you put in values for those. And as you can see here, it's a little bit of a very simple diagrammatic representation, but this is the Sapphira plugin, which is operating live in SketchUp, it's telling you what it thinks each component of your model is. So I've got the nearby adjacent structures identified as shading, so that with solar access, it's taking that into consideration. But thankfully, you can see here, my roofs are coming up as roofs, my walls as walls. This is fixed glazing. And if you wanted to change one, let's say something came through, it didn't look right, you can activate, select that surface, right click, go down to the little plugin menu that'll pop up, and you can just assign it as something else. So this is where you can, I know getting your architectural models into these cloud-based modeling platforms, that is always the most bewildering, labor-intensive part of the entire process. The fun stuff is once you have it in there, but what confidence do you have always that it's being properly interpreted? Here's how you can check that. So I'll hide my entity types and hide my entity palette. And you can see here, I've already set the analysis to go. I could do it again here, but it would take a few seconds. It'll give you 3 dials. It does some within SketchUp. It'll take a very quick, simple analysis of your EUI. In this case, it's 40 and it has your 2030 target. It's going to give you a very quick breakdown of the load profile. And that's going to be because I selected office and I selected Boston, Massachusetts. It automatically pulls in the climate data and load profiles for an agonizingly simple list of building types. Most likely your buildings won't fit nicely into one of these categories. The thing about Sapphira that makes it, it's sort of the best and worst part of it is it's simple. It's simple to access, less knobs and levers, but that plus will frustrate at times, but that it makes it very easy to get into. This is looking at the daylighting in my floor plates, and it's telling me what percentage of the floor plates are well lit, overlit, and underlit. You can go down here to some additional guidance. It's going to tell you the impact on your cooling load, the impact on your heating load. Okay, I can look at this and say, well, my south glass is going to give me some solar income, and that's going to help my building, right? Well, it is. It does have a benefit on your heating, but look at the deficit because it's a glazed component of your enclosure, how much of an impact it has on cooling. So you can really get in a, just very quickly, when you hit this update analysis within about 30 seconds, you get this richness of data. It's really quite amazing. You can just iterate, model, push, pull, twist, iterate. You can just keep hitting that green button. It's going to give you new numbers. And that is one of the best things about it is before you even get into the cloud, you can do some of this. Open the daylight visualization tool. Whatever view you have set up in SketchUp, that's what it's going to assess. And you can look at daylight factor. It sort of has the last 3 generations of daylight metrics. So it has your daylight factor. It'll give you your spatial daylight autonomy. It will also give you annual sunlight exposure as well. So the glare metric, it'll give you, you can look at just straight up illumination, and you can also, it'll give you a nice gradient, almost ecotech-like for those of you who've been using these tools for a while. It'll give you this nice colorful gradient that you can then export and use in a presentation. But as I'm talking here, I don't know if I'm going to get it in time. So I'm going to keep moving, and maybe I'll come back to this while it's baking. It's running some really complex algorithms in the background here. I want to, just because of the time is limited, once you are ready to go, you hit this upload to Sapphira button. Oh, there you go, right on time. So this is giving me, based on this scale at the bottom of your screen, hopefully you can see that. It's looking at a work surface height, 28-foot candles as the threshold, and it's looking at the amount of my floor area that is receiving a certain percentage of lighting. So this is going to be your it's going to be set based on whatever you establish for your spatial daylight autonomy. So you can get into these metrics. I'm going to close this visualization tool. When you click on this blue button right here, that's going to send it to the cloud. And that's where I'm going to try to do a new share here and show you what that will look like. So when you hit that, go to the cloud, it's going to give you what you see on your screen here, which is the equivalent of what you just saw with Cove Tool in the cloud. This is the cloud-based Sapphira tool. This is where you can really get into a lot more bells and whistles. If you were paying close attention, you would have seen that my EUI was 40. I imported it into the cloud. It's looking at things with a different level of granularity. It's making some slightly different calculations. It's just a bit more specific. It came up with 41 in the cloud. Don't be put off by that discrepancy. That will happen in any of these tools. This is very high level, very broad based, taking a lot of assumptions under the hood on these programs. But this is Energy Plus, if you're wondering what it's based on. And here we have pretty much the same UI at 41. You can see the annual energy cost. Also be careful when talking about that, especially with clients. They get hung up on that number really quick. Let them know this is just about comparing option A, B, C, D, etc. You can go to these tabs and you can start to dial up. It's going to bring in from your SketchUp model, whatever you had input there. I did not show you where you can actually shift little dials in that SketchUp menu item where you can actually adjust your wall insulation levels, your infiltration, some things like that. Just about 10 different things you can dial up and down, but you can pull it right here into the cloud. So here you might wonder, okay, infiltration, what kind of an impact could that have? Every one of these variables comes with this little icon. You see it right here, this little blue and red icon. I'm going to pick, actually a good one is, I'm gonna pick roof insulation. So let me find my roof R value. This is always a good one. I'll pick this response curve. I'm going to set it. Okay, so this is looking at R1 versus R55. You can change this to whatever you want. 10 steps. So it's going to run 10 different models in the background. And I want it to give me an idea of what that might do for my, let's say, annual energy cost and EUI. So I'm going to select these two metrics and I'm going to hit run simulation. And just like with the daylighting, I'm going to hope that the cloud is cooperating here at 6:09 Eastern in the evening and that they're not overtaxed. And I'm going to get this nice response curve where right now in the cloud, Sapphira is running no less than 10 different iterations of my model with taking basically the 10 even increments between the lower end of my spectrum and upper end. So between R1 and R56, let's call it. And it's going to show me what the impact would be on energy cost and UI. And while that's running, I'm going to go up here to the top and you can go through and you can select shading. You can look at different things. And I think I just got rid of my response curve. So space use, you can get into some of the mechanical things, air side. You can get into water side. You can add PV if it's on your project. It's going to give you also, as you run each one of these iterations, a lot of basics about your mechanical systems. You can change your mechanical systems up here. It starts me off with the ASHRAE baseline based on my location, climate zone, etc. And it's going to give you what you would expect to see in terms of annual, monthly breakdowns of the different ways in which your building is projected to use energy. Now, again, keep in mind that it's making a lot of assumptions. It's going to, based on what you select for your system types and these envelope enclosure pieces. But if this works out, okay, it's still running my response curve in the background. I'm hoping this will show up because if this shows up, you'll see one of the more interesting features of Sapphira. There it is, great. So this little green dot is the R30 where my project currently stands. It's just a little bit short of that actually. It's right on it. It's right on it. So you can see the diminishing return of increasing R values. So I had this happen to me on a job today where a developer was asking, can I increase my roof insulation? Will that help me get another lead point? Well, we've all had that day. You could show something like this and say, look, for that first R30, look at how much I saved in terms of energy. But then if I go from 30 to 60, very little. There's such a diminishing return that you find that sweet spot. You can actually see where that sweet spot is and make a pretty compelling case to spread the candy on your project. Look at different energy conservation measures, looking at things that have the highest impact for their effect. You can vary about anything with your project, the orientation, glazing ratios, system types, and you'll have this baseline here. You can copy it, make another iteration. You can make a dozen different copies of your model, change, pick it this way, change whatever you want to change about it. So the big one, see how it got big there? It says clone. I can clone it. I can change anything I want, hit go again. It's going to give me a direct comparison. And when you find a model you like, have it selected, and you can upload the project straight to the 2030 DDX, and it'll pull all the data on your project directly into there. It uses the API provided by AIA for the DDX. That is way too many acronyms in one sentence. And with that, I will stop sharing and yield the floor, and happy to answer any questions about this tool.
Well, thanks, Dan. That was actually quite an effective demo. I think it went pretty well overall. Few lags.
The cloud cooperated.
You know, all in all, pretty good. No, I think that was really interesting. We can certainly you know, entertain questions. I am seeing some questions, but I think they may be more global. So I'm going to suggest that we wait till the QA, and we can kind of talk in the context of all three of the presentations and some of the kind of common themes from them. But I think very you know, very compelling presentation. Thank you, Dan. Apoorv, are you ready to share?
Yes, I am. And so, okay, I am going to talk more about non-cloud product, which is Climate Studio. For those, I'm sure most of you are aware of what the product is or software is, but essentially the Solema team has been phasing out DIVA and ArcSim, which were the daylighting and the thermal analysis component or softwares in the recent past, making into a combined, much more streamlined package called Climate Studio. It's an entirely Rhino and Grasshopper based. There is a Rhino side of it, and you can use the same capabilities within Grasshopper. So it's really great because it kind of plugs in very early into the design process, as you know, Sherman and Daniel, both you guys mentioned about and Josh, you mentioned the importance of starting this analysis very early on in the process when you start, you know, doing your massing studies and things like those. That's when you need to get started. I will also try and hope that the live demo cooperates and everything works smoothly. You do see my Rhino window at this point of time, right? Okay, perfect. So I just, instead of picking up a case study or anything, I just picked up a random, you know, a sample building that Climate Studio had. And I'll go through three topics very quickly: daylight, thermal analysis within Rhino, and then thermal analysis within Grasshopper, and just give you a feel of, you know, the look and feel of how the results are visualized and things like those. Everything in Climate Studio, I'll try and not do a tutorial, but so everything works through layers. You know, a great feature of Climate Studio is that once you select your weather file, you can actually, in fact, visualize the climate information really quickly. You know, just what kind of wind situation it is, and just look at specific time of the year or you know, time of the day and things like those. If you want to see where the strongest winds are coming from, what temperature profiles those winds are, things like those, you can look at the diurnal temperatures, the hourly temperatures, mean temperatures over the day, over month, which again is really helpful when you start the conversation with the client in designing and everything. I love psychometric charts. Just, you know, gives you a good perspective about passive design and what kind of strategies you should implement, things like those. Another interesting thing is just, this is probably not looking the best also because of this part, but you can also do a heat map of various metrics, and, you know, things like UTCI are really interesting and important when you start looking at context and facades and things like those. You know, you can filter out the results and things like those again. But then the good part, and I've already run pre-run some of the simulations so that we can just talk directly about the results itself. So you have your Climate Studio toolbar with different analysis types. You can do a site analysis, as we just talked about. You can do a lot of daylight analysis, point in time, glare analysis, daylight. You can do your radiance rendering. You can also do radiation mapping, which is great and very early on to understand shading and mutual shading and things like those. You can also do view analysis now within the software. Both the daylight and the view analysis will give you a set report that can be directly submitted to USGBC as a lead submittal now. So I think that's a really good feature from the Climate Studio. And I know that daylight report at least also replaces the whole Excel workflow on the USGBC or lead online, which is a lot of time saved, especially if you have a complicated building. So again, I have a very simple office layout. For example, you have some workrooms, you have some conference rooms and things like those. And when you run your daylight analysis, this is this is how it looks like. It shows you how many credits approximately you're getting. This is run for lead version 4 daylight option number 1, so SDA, and not 4.1, but gives you what your spatial daylight autonomy is for the entire building or for the entire floor. You can also select specific floors or rooms or whatever, and it will give you, it does give you a list of the same metrics by each space. You get annual sunlight exposure, which again is really important. It's debatable how. I'll not go into the metrics, but gives you and tells you what's the glare potential, especially near the facades. So those things are really important when you're thinking of facade window to wall ratios, thinking about shading, for example, and that gives you also like spatial spatial layouts and things like those. It's a good help in that. You can get average lux out of it. So this is again very Ladybug, Ecotech color schemes that we are all very familiar with now. You have a great feature of setting what the high bounds and what the low bounds are on the lux levels. So it gives you a little bit more understanding of how things are working. You can also look at a specific day and then move the slider and understand how the sun moves. So that's usually when we do daylight analysis, we usually go in and do these checks, especially to make sure that our orientation of the building is correct. And we kind of expect that, hey, this is the west side, so afternoon you would get more daylight from the afternoon sun, but during the daytime it's more on the east side and things like those. So those become interesting and good checks for the daylight analysis. You can obviously print a report here. It gives you, if it works, I can show you how it looks like very quickly. Oh, I'm not sure actually if you will. Do you see a PDF pop up? Probably not. No, right? Okay. I'm not gonna go into that, but it's a very formatted floor by floor report, giving you exact these graphics in plan format and the ASE results, and then goes space by space to talk about where exactly and which space exactly is performing how well for the daylight. And so the other thing that they are starting to add, or it's still in progress, but it's already in the public release, is the view analysis. So this is again very well aligned with the USGBC lead view calculations and the credit itself. This is a very simple room, but for example, if you have a space where there are no rooms. It calculates the type of the 3 types of views and everything, and will give you a score if it's if it meets the requirements or not. You can look at the view factors based on how good or how bad the depth of the views and things like those are. I think it's pretty seamless. Again, you can get a PDF report directly out. You can also export data directly in an Excel format. And then the good part also for both daylighting and view is if you click on the I button here, you do get what kind of materials you have applied and what kind of reflective percentage and visual transmittance for that material is. And those are again really, really important but good QA/QC points to check. As you all know, this is a daylight model, so it's a little bit more complicated. When you go into an energy model, it's a more single line, single plane model that we have to create within Rhino. Again, it works all based on layers, but sorry. 1 second, sorry about that. But when you look at, and I've pre-run some of the results and simulations so that it's easier to show and talk about this. But once you set all the zones and all the materials and all the zone properties and everything, and you run your results, this is what you instantly see. You see a site EUI, operational carbon and kg CO2 per square meter, energy cost. Again, Daniel, you mentioned these are all comparative analysis pictures and numbers. They are as good as the data you are defining, garbage in, garbage out. So really, really important to make sure that we define our input data as closely as possible. But even at that point of time, it's really important to see all of these simulations as comparative iterations and not anything else. Climate Studio also within this window, again, this is all Rhino based right now, but it gives you a baseline EUI, which is basically the CBEX 2003 data, which is also the same data used for AIA reporting and EDX and the 02. And it will also give you how much percentage saved compared to that baseline. So that's your AIA 2030 score. I seem to be very good in this and saved 76%, but we have to keep the idea being save as much as possible and meet your 70%, 80% goals there. So what you see here in the graph is energy use intensity, which is kilowatt hours per square meter, broken down by end users and by months. Really important again to check and see if things look mean or look right. You have options of going into energy use, so it's more kilowatt hours, which again can be used for thinking about PVs, for example, or understanding of how much total kWh the building is consuming. I really like and highly recommend everyone to use the energy flows for any tools actually that you use. Energy Plus gives you that option for a general simulation. What this gives you is heats and the gains and losses. Again, I think Daniel, you showed that in Sapphira. What are the things that in the building design that kind of contribute to heat gain and that contribute to heat losses. So you can see that it's a lot of mechanical ventilation, for example, but there's also a lot of window conduction gains, which means we have a large window area right now, for example. In fact, I should have turned this off. So right now this one was a fully glazed, 100% glazed window building, so you can see it's a lot of conduction losses happening through the windows. And so for example, if you go to a smaller window proportion from here, you can see it's automatically much reduced or much lower losses through windows, still using the same kind of window glazing assembly, which is the double pane glass right now. The other interesting thing also is the zone level information that Climate Studio provides. So you can select any zone out of this and start to get what are the temperature profiles happening throughout the year. It shows you a zoom in for a week, which you can select from here. But that's also really helpful to understand and to see that you've defined your set point for the HVAC at 26 degrees, for example, but your MRT is higher. So your walls are getting much warmer, and therefore your operative temperature is somewhere in between. And things like those, again, becomes interesting checks and good checks to have. You can also do energy flows within this. So it's a more of the energy flows diagram that I showed for the building. It's now this is for each zone. So you can see, you will be able to see the difference between a north facing zone versus a south facing zone, for example, in terms of heat gain and heat losses. So that's a basic idea, but another interesting feature of Climate Studio is that you can now actually, in fact, select multiple of these iterations. And if you click on the compare button, you see something like this. Do you see a new window pop up with multiple comparative bars? Okay. So this is, I really like this feature on this comparative workflow and visualization. It's showing you all the things or all the simulations that you added that you're comparing. Shows you the same bar charts and uses annual and uses breakdown, but then shows you exactly what has changed, what has gone up. So I don't know if the gray arrows are visible, maybe probably very faint, but any value that changes in any of these comparative analysis, you see either a gray arrow pointing down or pointing up. The other interesting thing is that it also goes through the entire input assumption list, which is really important for everyone to check once you have run your analysis, just to make sure that whatever you're defining, again, garbage in, garbage out, that you're not into that trap of thinking that you have a single pane glass, but you're actually defining a triple pane glass and getting really excited about the low UI when the engineering report comes in with a very high UI and things like those. So again, everything that whatever you change, you will see a difference in there. And it's always previous to the compared to the last change. So for example, this is 0.59 because that's where I changed my double pane glass to triple pane glass, for example. It also shows you a negative percentage reduction here on the top. You can export all of these bar charts, input tables as PDFs, as Excel files. And if I go here, again, talking just a little bit about the garbage in, garbage out, I'm going to go in here. It's really important to know what you're doing and what to expect. So this is me going in and just randomly switching on natural ventilation, for example, for this building. And the results look like this, which don't make any sense at all, right? Why would there be? I mean, it can very well happen, but that's not the building you're designing, and that's not the building how you will be controlling it, and things like those. So just an example, and caution that always look at more of comparative analysis or comparative studies, and if you see something off, there's definitely something off. Double check. The last part here is that you can again export all of this data into Excel formats. The reports is typical Energy Plus HTML report. The data is zone by zone, each metric being exported as raw data. You can also export the IDF out if your consultants, engineers are asking for it, or if you want to take a look at what is being really defined and make sure everything is fine. And then the last thing, which is great again, is you do get an option of exporting this whole thing to AIA DDX. So you put in your firm key and your user key. make sure all the data is correct. And once you submit to AI, again, I can't, sorry about that, but I can't, I'm not able to show you the Chrome window here, but it will appear as a project, exactly the same information in the units that you are trying to look for. The last part about it is a very quick, very quick thing that this exactly the same capabilities, in fact, actually exist on the Grasshopper side, which again, I really like, because we are all in this world of excessively parameterized design approach, which also is great. But you can link and you can do whatever you want to do with Grasshopper, have Climate Studio run multiple iterations overnight and things like those, or run as many iterations as you want. Everything is displayed. You can display everything in the same format within Grasshopper. So this is your UI, but you can also do your energy balance, for example, and things like those. The good part is that you can also, once you have, if you have provided a directory and the name, you can actually go back and load that same result file into Rhino and do the same exact analysis and everything within that within Rhino as well, and do the comparative analysis and everything. Yeah, in terms of, again, just quickly about quality check and QC, use energy flows, use PNNL databases, and use logic to see whatever you have defined the model is behaving in a similar in the way expected, because there's a lot of things that can break. Always see what you're defining. I'm going to stop sharing now.
Thank you for that. Was quite a robust presentation, or tool, I should say. I think that yeah, clearly there's a lot you can do with that. I don't know how long you've been using it. I think it's a fairly new program, Climate Studio, is it not?
It is. It's been around for a few months, I would say now. Again, in the previous life, Diva and ArcSim used to be the components, and it's very similar, but now just packaged into one single thing, much robust UI. There is, I would say, there's a moderate learning curve to it. It's not very tricky. It's not eQuest, and it's not Sapphira. That it's not a click of a button. So it's kind of somewhere in between, which is, I think it's great, because you get to think about what you're doing before you can see anything.
Well, thanks. I mean, I think all three of those tools, I mean, I think they start to show, some of the capabilities, the investigations that architects in particular can pursue with and again, the emphasis here is on comparative tools. The types of manipulating the types of variables that architects are comfortable manipulating. Envelope orientation, looking at daylighting, those types of qualitative and quantitative things that have a direct impact on our designs. And I think I thank you all for highlighting kind of some of the the nature of the outputs and the kind of the linkages to the DDX. I think clearly we have to be a little bit skeptical, and I don't mean that in a negative way, of the of some of these comparative outputs. They are to be validated as we kind of move forward, as we introduce systems into the project. We'll talk more next month about kind of later phase validation, verification type energy modeling and the lessons from that. But I think using these tools as an iterative design tool I think it can also carry on through phases, and I think you could see probably where some of these tools, may be oriented more towards conceptual phases, schematic phases, and where some of them may be able to carry on a little bit longer. I think that's kind of an evaluation that that each of us could make towards our process, and I think just a quite quite a range of tools there. So so as we go, from the interpreting of the results that each of you spoke about, and kind of what the lessons are from those, there are some kind of basic reporting and QA type of checks that you can also do through the DDX. I mean, as I know we've said before, and as Janki said at the beginning of the talk, you want to set up your project in the DDX, early on. It's pretty easy to establish what your baseline is. You really have to enter about 5, 6, 7 inputs. Your zip code, your building type, the size, a few more things, and you get to the CBEX 2003 baseline, which is I guess the 100 of the AI 2030 spectrum, getting down to 0, as in terms of the percentage reduction. And then once you have that, you quickly, the DDX helps drive you based on your building type, and codes, and a few of those other inputs, to what your target would be to meet the 2030 commitment. Another thing that should be noted about the 2030 DDX, and I know that some of these programs that you guys were running us through, pull from the baselines and the targets of the DDX. These DDX targets and baselines are kind of underpinned by this 0 tool that the Architecture 2030 challenge group that Edward Masria had started a long time ago has created this 0 tool, which you can actually access independently to help identify energy reduction baselines and targets for your buildings. So and so you can kind of get to a lot of that information through the DDX itself, through the 0 tool. Just a quick note too, if you're working on working on a lab building, the laboratory benchmarking tool is kind of a step that you have to take outside of the DDX to really benchmark your lab buildings. But there's a handful of inputs. You can usually find a couple of, you want to find about 8 to 12 comparative lab buildings of your type in your climate zone, and that'll help you establish that target and baseline, and you can then come and enter that as a custom baseline into the DDX. And then I think that the other thing that we want to just talk about big picture is, once you've done this for your firm portfolio, you start to see the trends in how do your lab buildings perform, how do your office buildings perform, how do your healthcare buildings, whatever how do your multifamily buildings perform. There's quick lessons that come, and then there are tools to view your entire portfolio through the DDX as well. So I just want to kind of emphasize those, as kind of additional benefits and checks on reporting to the reporting process for the 2030 commitment. And I think at that point, I would like to kind of go to our questions, and I can pull up the chat.
So Josh, there was a question that we started with, and Dan kind of answered part of it, but just for the rest of the audience, and so it's part of the recording, maybe we can just have Dan talk a little bit about the difference between, so the question was, what benchmarks are the different tools using and how do they relate to 2030? And Dan responded, the benchmarking tool that the Sapphira tool is using and alternates, right? Like you can set a different benchmarking tool. So Dan, can you talk a little bit about the difference between the two? Because I think this is a really important topic to discuss. And then maybe Sherman can chime in on the Cove tool side.
Yeah, definitely. So the way that it would work if you had the Revit or SketchUp plugin. So I showed that SketchUp plugin. And I'm tempted to share screen again, but I don't want to. I know we've got limited time here. Otherwise, I would totally do it. You would go in, and it actually has preloaded in the SketchUp plugin a limited set of baseline assumptions. It basically, when you say, okay, my project's located in Boston or Indianapolis, wherever it is, it's also going to know now where your climate zone is. And so when you pick one of the limited sets that they have, say ASHRAE 90.1 2013, you could pick that and it would pre-arrange these inputs in your model, your wall insulations, your roof insulations, solar heat gain coefficient for glazing, et cetera, et cetera. It would set those to what's essentially, at the risk of oversimplifying, essentially the equivalent of the ASHRAE 90.1 prescriptive path baseline assumptions, like minimums for your building. And you can change it then if you want. What I've had to do, because Indiana, we're based off of 90.1 2007, and probably half of you just gasped when you heard that. So we've got a very old energy model. I actually have to make my own baseline in there. So I have to set the dials just like we need it to be a minimum in Indiana. I've saved that now in my install of SketchUp and the plugin for Sapphira. So all I have to do is hit the 90.1 2007 commercial baseline that I've put in there, and it populates everything for me. And then I hit that blue button, go to the cloud, and everything's the minimum. So it's, you have to define your baseline in Sapphira. It won't give you one, but in that first dial in the SketchUp plugin with the EUI, it had that little green dash. That's marking where the 2030 challenge threshold target currently is. And even though now we're trying to push toward net zero, so ideally we'd take it even beyond that. But that's the long-winded answer. The short answer is you have to make your own, and they help you set your own up really quickly, but you have to set your own.
Yeah, and I think the importance there is like Zero Tool, the baseline there is from 2003, so it's even older, right? So when you see you put Zero Tools like use that as a benchmarking tool, and that's your baseline, you're gonna see a % reduction greater than if you updated your baseline to meet whatever energy code your jurisdiction has. And so there's a disconnect there, right? Because Zero Tool is an even older baseline. So it's really important when you're looking at those % reductions to pay attention to what that baseline model for energy use is, and not worry if your percentages look off for what you're submitting to your local license and inspection or building department versus
And
what you're, go ahead.
Chunky, you touched on a really important point there too, that with these early stage tools, it's quick, it's iterative, it's high level, and while we're working with numbers, we don't want to get caught up in the numbers too much. I think it's always that relative one option versus the other option, figuring out the order of magnitude to whittle that down. But then the point raised earlier as well about junk in, junk out, there's kind of like the designer's intuition. If it doesn't smell right, if you're seeing it like this is either looking really, really good or really, really bad, there's probably a problem with the inputs. And I think that's that designer's touch in all of this, that we still have to sort of let it pass that gut check.
Yeah, and just to add to that, Cove tool, those tables we look at a % reduction, it builds in reference to the 2030. DDX goals. So that would be the 2003 CBEX. When you enter data for a project, you choose, as Daniel's saying, which code you want to compare to. Now it runs the baseline for your design based on that compliance, ASHRAE or IECC, and it creates the model. Then it tells you, okay, here are options to reduce your energy use from that model. So there's two benchmarks. The one that DDX wants, which is what Josh was getting at before, we can report and see that how it fits. And the one that you really need to say, okay, for code compliance, I need to meet this. Am I meeting code compliance? And what the options to improve it. So I think probably all these tools allow you to do that.
Okay. If anyone does have any questions, you can feel free to unmute and ask the question. There was one more question that was asked by Guillermo, and he was curious about the cost of this type of analysis and studies. And I'm assuming he means like an internal cost, like time commitment to doing this internally. Like, can any of the presenters speak to how it impacts your everyday workflow?
Well, just to say these initial concept studies, it was a matter of several hours to get up and running and get useful information. When we did a more complex high-rise building with sunlight, daylight, and glare reports, that was a day or two's work to get a useful output and report. So it's from a few hours to as far and deep as you want to go, which I think Daniel and Apoorv might agree as well. So.
And my answer to that is, assuming that you're familiar with the tool, that you're conversant with the tool, because there is a learning curve to all of these platforms. If you are up to speed on and you've got everything working on any project, it's really a matter of what question are we trying to answer? Because if I'm going to look at daylighting in concert with energy, and we're looking at several different components of the enclosure or mechanical systems, my effort's going to balloon. If I'm looking at just getting something in the system so I can assess it from a EUI standpoint or such, it won't take too long. I will say two things. When I run just kind of a general, I have a template internally when I'm just doing a general energy and daylighting assessment, and that will take me on most projects around 4 hours or so. And that's assuming I get the project, a model from the design team that I'm working with that is useful. If I have to do a whole bunch of fix up to the model, it might take longer. So it typically takes me 4 to 8 hours. And that is if I get a messy model and I'm trying to interpret things and make it so that Sapphira can take it in. And then I'm also working on getting numbers out of the system and in a way in which I can send it out to people. So we're talking gate to gate total effort. If I'm talking just doing Sapphira as an analysis, it's just a fraction of that. It's probably 2 hours in the program, just going through and looking, probably less than 2 hours. Really all the time is in getting the model working and then pulling out information and putting it in a package for whatever I need it to use the package for.
That's a great point, Daniel. And I'll give a more intangible answer to this whole thing. I'm on the engineering side now, but I have worked as in an architecture office as well. When we talk about the time it takes and the time that as an architecture practice you have to spend on it, I feel it's a, again, as I said, an intangible answer, because if you are really committed to it, then it's also the time that you will spend waiting for a detailed report to come back from a consultant, versus if you are able to do this on every single iteration and keep optimizing your design in an attempt that once you pass it on to the consultant, it's already aligned, it's already in the right direction. So that's a lot of time saved rather than thinking about time that you spend on all the analysis. And I think what you were mentioning, Daniel, I think that's we've again in my architecture life, we've talked about thinking about these models as not analysis models, but when you're modeling in 3D in Rhino, in Revit or whatever, thinking about these models as 3D printing models, free of any holes and everything. It might sound like a small thing, but eventually it does have a big, huge impact, not just from an analysis perspective, but I think we all are moving in that direction of a cohesive tool workflow kind of a situation where the models should be very easily passed on from architecture to the consultants. And I think more we think about those, just modeling guidelines and everything, those things will start helping us reduce the time that we spend on remodeling all of these, glass glazing facades and stuff like that, and spending more time on just optimizing the results.
Yeah, thanks, Apoorv. And we actually have one of the developers of Cove Tool on the line. Nilesh Bansal just posted in the chat. If you guys have any questions for Cove Tool, Sherman, if your office has any questions, this is a good time to ask anything related to energy modeling, or anyone in the audience. We have a surprise fourth presenter here today.
Thanks, guys.
Yeah, Cove Tool has a great support team, and they're always available. So that's passing that on.
Yeah, you reach out to us, we'll get back to you in less than 5 minutes.
Right.
Does the energy modeling, it's architects coding that their buildings, but is there a way that it's collaborative and very interactive with the engineers at the same time? So it's not just, well, let's try this, but the thinking of the other disciplines as a multidisciplinary approach. Do these various energy tools, the Cove tool, integrate the structural engineering and the materials for it, as well as the whole HVAC system as part of that modeling, as part of that whole thinking process? And a long time ago, when projects started, it was a team sitting down at a conference table. And then when computers, it would be an architect, unfortunately, would design something and then email it to somebody without the conversation, and they make it work, as opposed to that. These are very proactive thought processes. And then at the same time, it made me think back on the classic pioneering book of Design with Climate. So it's an age-old topic, more prevalent and timely than ever. But are these tools also incorporating the engineering in that early analytical stage of the design, evolutionary stage of the design?
Go ahead, Daniel.
I think we could have a whole discussion on this. I know I use Cove Tool and Sapphira, and both of them allow the engineers to get into the programs. Just like you would invite somebody to your Dropbox, you can invite somebody to your cloud-based energy model, and they can get in there and start trying different schematics of mechanical systems. And it's been a wonderful process. I've enjoyed it.
Cool. But part of the thought process with the architect as well. So it's not like, well, try this, but let's come up with the scheme that does all of these things.
It does, and there's I can't say we've got a great way to get the structural engineer in the mix yet, but in terms of the mechanical engineer, to really bring in to have those discussions much earlier about different schemes for the HVAC system, and okay, what might we need to do for lighting power density, and you kind of go through a lot of different variables while we're also in real time changing enclosure options and really starting to, okay, now that external sunshade package is reducing my tonnage, and that's saving money now. Now it's not going to get VE'd out because we've optimized our mechanical systems based on that reduced load. So it's helped us have a more integrative process. I would say to the essence of your question, it's actually the cloud-based energy modeling platforms have helped us integrate our design efforts with our mechanical engineers better than we did in the past.
Cool. Thank you.
Yeah, and you know, I think, Daniel, when you think about the things, these decisions you can make early in the architectural design process, you know, so many of them impact the loads, the HVAC loads, and in doing that, it is a kind of a holistic, feedback loop. You could certainly try to get in and compare mechanical systems, but I don't think that's inherently what these programs are about. And certainly, Purv, you could correct me if I'm off.
Absolutely.
But yeah, as you kind of get further along, in the process, then you start doing those kind of higher level. You want an engineer doing some of that modeling.
Yeah. Exactly. That's the trap, that garbage in, garbage out trap. I mean, I don't see any reason why we should not. And I think, so coming back to Climate Studio, except defining a detailed HVAC system, you can pretty much do everything else. But in terms of just the mechanical systems, it's limited to COPs. And the reason why the Solemma team is very clear that we want to, the intent for Climate Studio is to be used during the design process for a comparative analysis for best practice design. And you can export the IDF and introduce your systems and do whatever you want to. But it just the speed and the ease of using this thing or doing an analysis with accurate result is what matters, I think. I've seen people get into that trap of defining a lot more and going, I mean, the natural ventilation example was a clear example for me, at least, that, I've seen that happen so many times, that you define one thing wrong and everything is wrong, and you don't, you can go in and report those numbers and be excited about it. There are a lot of traps.
And that's a really great segue into our next series, actually, Josh, and Marjorie, your question. So like next month, we're actually going to do the same thing, but we're going to do it with engineering software. So like what does the reporting look like from the software that engineers use? Because the intent is to elevate our understanding of energy modeling metrics and start having those conversations earlier on, right? Like let's sit down at the virtual table and talk about these numbers. The month after that, a couple of the presenters actually showed you today what an energy model looks like in 3D versus an architectural model. And there are a lot of interoperability issues with translating an architectural model from energy modeling. And there are tools and processes that are working towards solving that. And so in November, we're going to talk about how can we break down the barriers to collaboration between architects and engineers from the modeling standpoint. So I really hope you guys can join us for that session. It's going to be, actually all of these sessions are going to be really informative. And in December, I'm sure this is on everyone's mind, and we had Guillermo asking about like, how do you price this out? That's a great question. And it has to do with contracts. So in December, we're going to talk about how to design your contracts to include energy modeling, because that's a big part of how to work together to build better buildings, right? We have to have the engineers on board because we can't do it, right, all accurately. So I hope we'll see you guys then. And then we do have our local chapter. Josh, if you can go to the next slide.
Sorry.
Thanks. We have our local chapter COPE meeting this Thursday from 8 to 9 a.m. We hope you can meet with us, join us. I think we have someone from CLF, if I'm not mistaken, presenting. And our subcommittees, we're always looking for volunteers. So if any of these subgroups or topics are of interest to you, please do join our meetings. And you can subscribe to our calendar to know when they happen. All right, thank you, everyone. Thank you to our
very much.
presenters.
Thank you all. Yeah, thank you to
Thanks, guys.
Dan, Apoorv, and Sherman for your presentations, especially.
All right. Have a
Thank
great
you.
night, everyone.
Thank you again.